Okay, I think we're ready to start. We seem to have pretty much everybody online. I'm very pleased this week to introduce the first guest speaker, Tudor Gerba. Tudor is the founder of Fink GmbH, a small company consulting company in Bern, a software engineering company. And they've also being responsible for the development of GT, which we've been using for the last few weeks. So I'm very pleased to introduce Tudor, and he's going to tell us about moldable development and how GT supports moldable development. Okay, Tudor.
Well, thank you. It's a pleasure to be here. To be somewhere. And so today we're going to talk about moldable development. I've been looking at the courses that you already had, the lectures that you already had, and so it's pretty exciting to see how you already got to see, to look inside Smalltalk, to see how reflection works there, what the object model is, and then to have played a little bit with Glamorous Toolkit. And today we're going to go a step further, basically taking from where you are and going a step further towards the larger picture as to why this is interesting. So my name is Tudor Gerba. As Oscar said, I'm the CEO of Fink. At Fink, we wear two hats. On the one hand, we're a consulting company, but on the other hand, we internally act like a research lab, and our long-term goal is to make the inside of software systems explainable. And by that, we mean that we are building tools and techniques to reinvent how we can possibly do that. So why that? Well, if we think about software development, if you think about what development means, it's most often this is associated with the active part of constructing something. Like I don't have it, then I develop it, and then I have it. It's a very empowering, and it's pretty cool because with software today, like we are impacting everything. And it's an empowering thought to think that we are building a whole new world on top of software. However, when you look at what developers do, it turns out that they don't develop all the time. They read too. In fact, people say that they read about at least 50% of their time. So they read code most of the time. And this is an interesting thing because 50% or more means that this is the single largest expense we have. There's nothing larger than 50%. So perhaps it's worthwhile taking a look at it. Now, if you think about, so when we go and we talk with developers, we ask them, so when was the last time you talked about not the code that you're reading, but about how you do the reading? And it turns out this is not a subject of conversation. Like people talk about indeed what they read, they talk about their systems, but they don't really talk about how they perform the reading part. And that's interesting because if you don't talk about something, it's not explicit. If it's not explicit, it means you can't inspect or introspect or reflect on it. And because you cannot do that, you also cannot optimize it. So that's a big problem because, like in business terms, you would say, well, we spend the largest chunk of our budget on one single activity nobody talks about. Well, so let's talk about it. Why do people read code? Well, people read code because they want to understand enough to make a decision. They don't read code like you would read a novel. They also don't read code like you'd read a textbook in philosophy. There's a very specific intent typically, and that is associated with what do I need to do? So maybe what's the root cause of this bug? Or where should I implement this new feature? Or what's the impact? What are the side effects of doing or performing a certain change? So really the goal here is not reading, but it's decision making. And this time the developers spend reading code is mostly the primary time. It's like it's the raw time that people spend to transform data, which is what the system is, into information, the necessary information to make decisions. And this is just what developers do. But the further away you go from the code, that's pretty much all everybody else is doing. Everybody else is just simply taking information, some information, and then choosing or making decisions based on it. And so, not talking about how we go from that, the system to the decision is not really a good thing. Now, if we do talk about it, then we realize, well, reading is not the activity. The activity is making the decision. So reading is just a strategy that we use to reach that conclusion. It's a specific, tool that we are employing to extract information out of data. But if there is one tool, there may be others. But you can only find them if you talk about it. Because if you don't talk about it, it's like with Voldemort, right? You can't fight it. So we talk about it, and a long time ago, I called this specific activity of understanding enough a situation around the software system in order to make a decision. I call that one software assessment. And this whole idea of moldable development, and the reason why Glamorous Toolkit exists, is specifically to focus on this part of the activity. So that's the larger picture. So what exactly is moldable development? Well, let's take a look at the simplest pieces in a software system, and that's an object, well, at least in a typical software system. So if I look at an object, the way I want to reason about that object is through some tool which is called an inspector usually. So and an inspector is typically defined as being a tool that shows us the inside of an object. So it shows us the structure of an object. So I can see variables and values. And that's pretty interesting because it's a tool that I can apply on absolutely any object in the world, regardless of the language, right? It's something that is super generic. It's very nice because I can implement it once and then use it many, many times. And so it's great. But here I have 6 objects. And these 6 objects, I'm showing them through 6 inspectors. But if I stay, let's say, like half a meter, 1 meter away from the screen, there is no way for me to distinguish between them. I don't know what's inside there. So simply showing me the interior of those objects in their raw form, generic raw form, is not particularly useful. It doesn't help me understand in order for me to get educated so that I know what to do next about them. And that's interesting because the problem here is that generic views, while they are applicable broadly, they are also not particularly interesting because value is always contextual. And software is the most contextual thing we've ever created as human species. We can create enormous complications at a very small scale. So maybe a team of 10, 20 people, they can create really, really complicated systems in a reasonably short amount of time, so maybe a couple of years. So that's why context there is so important. So if I take these views, if I take these objects, and I only change how I look at them, right? I only change the views, I only change the projections. Then I can start to see that I can feel that they are different. I feel it very, very quickly. And I feel it at a different level than by looking here. There was a lot of analytical things I would have to go inside. So maybe here I can distinguish that this is 21 divided by 2. But here, this is a little bit difficult. I can see things. So it's much harder. But if I look at it like this, then it becomes easier, right? Here's a fraction. Here it looks like a folder. So if I scroll through it, I can see that this is a folder. This looks like a picture. And this looks like a Bezier curve, and this looks like some sort of an algorithm. And yeah, this looks like a data structure. So, so the interesting part here is that the only thing we have done is, or was to change how we're looking at it. We are not changing the content. We are only changing how we are looking at that content. And that's basically the essence of moldable development. There is no single perspective that unifies everything. There is no single perspective from which to regard a software system, because we are interested in that, in any fact about a software system. Any fact about a software system must be regarded from the specific context and from the specific point of view from which we are looking at it. For example, if you're just think of a system, and if I have a performance problem, I will be looking at it in one way. And if I have a security problem, I will be looking exactly the same piece of code, but in a different way. I'll be concerned with something completely different, which means that the perspective from which I'm looking is rather important. And this is also interesting, in the context of what you were talking recently about, which are models. Because this view is nothing but a model of the thing that I'm looking at. And so is this other view here. It's a model. So, and it's a model specifically geared for me, for my understanding, right? They are all somewhat incomplete. They never show me everything, but they are useful, or they can be useful for specific purposes, right? And that's the interesting part about models. And usually all models are incorrect, but some are useful. And the usefulness of a model is usually given by the context from which you're looking at it. So, as a consequence, if we live through it, or if we live up to this principle, it follows that our tools, if I now look at our inspectors, our tools should never assume anything about how a specific, for example, object should be displayed. So here we have different views. So these are inspectors. So I can look at them through their raw views. Of course, any object can be shown to their raw view, but at the same time, different objects can host different other views. And this is where that's the essence of moldable development. And the reason we created Glamorous Toolkit is specifically to explore. At the beginning, it was mostly a research question, to explore what's the implication of this. And the reason why we spent all this amount of time looking at it is because we look at, if you think about software systems as they have fractal-like properties. That is, regardless of at which level of abstraction you're looking at them, at the software system, you will find similar patterns occurring in different shapes, but similar patterns occurring at the different levels of abstractions. Which means that in such a system, if you want to affect the coarse-grained patterns, you want to be able to affect the smallest unit. So our goal was, can we reimagine how developers read code? And in order to answer that question, and usually, like for example, during our projects, we might be looking at systems that have, implemented in some mainframe system, some mainframe language, and some combinations of Java, JavaScript, and COBOL, and maybe having like 15 million lines of code. And so it's a large system. But to deal with that problem, our hypothesis was that it's enough to, or not enough, but we have to first focus on the smallest possible problem. And the smallest possible problem is, how do we relate to a single object? And that is why most of our effort during our research was spent on imagining and reimagining how we can relate to a single object. So the idea here is, right, that we have principle number one. Here is there's no single perspective to look at anything in software. And as a consequence, our inspectors should not assume anything. So this this view over here, right, this is a fraction, so it shows me this. So this is rather simple. But here I have an instance of file reference. And because this file reference points to a folder, I can see the contents of the folder. But here I also have a reference, an instance of a file reference. But in this case, because it points to a picture file, there is a picture over here. So the other interesting thing here, but both of them have this path view. And the path view basically says that because they're both file references, regardless of this, whether it's a folder or it's a file, they both have a path. And I want to find out if those paths are valid, basically. So that's why you're saying all of these folders exist in the path, right? And then similar things we're having over here, right? This is an element, and this element will have many different kinds of perspective. You know, we will know what it has, what metrics it has, what kind of you know, what types of properties it has over here, the background, the border, and so on. And then the same thing would have here. So these are up to here, like a fraction, a file reference, and a BL, and then block element, which is, these are generic things, like you will find them everywhere in the environment. But here, this is a very specific object that's called, which is a part of an algorithm to identify the larger part, or the how to place things in the scene. So it's a layout. And here, this specific object is a little tiny object out of the larger layout object. And this specific object is concerned with, given a C1 object, a C1 element and a C2 element, and given this space that we want around them, where can I put this third C element? And basically, the way you're doing this is you're building a triangle and you're drawing a perpendicular, and then you're going to find the intersection there. So this is why we're having, and this view over here is, it's interesting from a documentation perspective, but it's equally also interesting from a debugging perspective. So we're actually creating these tools as we are working on our systems, and through them we eliminate the need to read code. So not always, of course, at some point you want to read some code. But most of the time, developers spend today on reading code. They're actually spending on something else. So that problem is not a reading problem, but it's a search problem or a visualization problem. So here, for example, we have a text file, a text object, and you can see it. This is a rendering of that text. But equally well, we can say, well, what about how is this implemented inside? So this is like the data structure that makes the whole text editor be fast enough. Like this is like it's called a rope data structure. This is something that exists behind. I can look at it as if it's a piece of text, just a piece of string. And so here, when I click on one of these, I can see the position on the left here. And if I click on something if I click on something here on the left, which is the position and the characters, then I can see where it is here on the right. And this is usually, it's very interesting when you're navigating and you're trying to find, parse files. Let's say this is the end of a line. And so the question here is, what do we have? Do we have a CR? Do we have an LF? Or do we have a CRLF? Which is, again, useful when you try to analyze some stream of data. And so this view here shows me, okay, there's a CR over here between R and C. So that answers the question. But then you can go also meta. These kinds of views, they can be used for all sorts of purposes. So here, this is where it's interesting. This is actually a little view that is instantiated based on, or this is generated based on the contents of this file, of this object. and it generates a piece of code that when executed, it will produce the same object as we have here. This is very interesting, for example, for debugging purposes. So let's say somebody says, oh, there's a bug in the text editor. And because we have built our own text editor, there were bugs in the text editor. There still are. And so in order for us to be able to evaluate those bugs quickly so that we can communicate with one another or how to reproduce that bug, then we created this view here. So what's interesting about it, again, this is a meta level view. It's not, it's about what's the code that when executed will produce an object that is basically the same as the one that I'm looking at. So what do you do with these views is completely freeform, and they can be used in many different ways. Okay, so let's look at what this means, that there is no single dominant perspective on any aspect of software, which is the core idea behind Moldable development. So to do that, I will start here by simply looking at the current folder, right? So here, this is a dot, and then I'm passing as file reference to it. If I execute that, I will see here I will see here the contents of this folder, right? So I can see what the path is, exactly like I saw before. And what is interesting here, so when I clicked here and I executed this piece of code, and I can see I get an object, and the object knows how to present itself. So it shows me this, which means that if I now click on some other thing there, I'll get a new object, and this object will know how to present itself. In this case, this is a folder, so it shows again those folders, which means that now I basically have simulated here it's like a file finder tool, right? But I'm doing it in an inspector. Or similarly, if I see here a picture, and this is basically a rendering of the slides that I'm showing you right now. These are, then again, like these are, because this is a JPEG, so I can see that this is a file reference pointing to a JPEG. It shows me a picture view, which shows me the preview of that picture, right? So it's a very simple way to build reasonable interest or an interesting tool to navigate files. But then, of course, here we can have also, hex representation, because that's another representation of a file. So let's go a little step further here. So let's say that we go into a folder, and in this case, in this specific folder over here, we can see this is a JavaScript project, JavaScript-based project. And here, for example, we're having a JSON. And what's interesting about a JSON is that I can see here there are these def dependencies over here, and I can see what those are. And I can see there are some other dependencies over here. And what I can see what those are, right? So one way to look at them is to look at it as if it's text, right? And then I'm gonna go and navigate in this way, right? And I will maybe search and do Control F to find something. But another way would be, well, what if I have that JSON, and what if I know how to parse it? And when I parse it, right, when I parse a JSON file, I will get, in this case, I will get a dictionary with keys and values. So here now I can see, okay, these are the dependencies. And when I look inside there, this is now a dictionary, another dictionary. And this is now something that I can now query. So if I'm interested, for example, here, I will just open here a playground. And in this playground, if I'm saying I want to, so self is gonna now, this is an object playground, not a generic one. So self is gonna point to this dictionary. So let's say if I say self size, it will tell me 40 because there are 40 items here. But we can say here, well, I want all the keys, and I want to select each of these key that begins with something React. I just want to find out what are all my dependencies that are depending on React. And this is the ones. These are the ones that are just about React. Okay, something happened here. Okay, so these are the ones that are just about React. Right. Okay, so are there questions so far? Because I have a question for you. No. So the question that I want to ask now is, how would you name this tool? So this is a file browser over here. Then we have an editor. Then we parsed out of that editor. We got a dictionary out of which we are selecting to find out which of our dependencies are actually based on React. And so that's another interesting thing. So because all these interactions that I've shown you here so far are happening in an inspector, and the inspector is supposed to be the most basic tool we have in our development environment. And in most development environments, the inspector is barely used. On the other hand, if you flip it around a little bit, like if we only change the question, so instead of asking, instead of defining the inspector as being a tool that shows us the inside of a software system, we are now defining it as a tool that helps us understand an object. Well, all of a sudden, there can be many different usages that would have otherwise not been available. So, and that's one interesting aspect of moldable development, that is, once you break free from this paradigm of having to go to a tool that is designed for a specific interaction, and rather just focus on your data and then let the tools come to your data and have you be able to combine them in any way you want. Just switching this paradigm opens up a whole new set of possibilities that you would not see otherwise. So let's go a step further. So let's see how much further can we go with this. So let's go now inside the source file and in source folder, and maybe there somewhere there's some JavaScript file. If I look here, I can see this is JavaScript file. And let's say that you want to now say, well, what's the structure of this file? So again, like how many functions maybe there are there. Or so what you want to do now is to go and parse this and basically get the contents, or look at this file again from a data perspective, not from a textual perspective. Because the reason people read code is because what they are presented with is a giant text editor. And once you see things like as being text, then reading seems like a very normal thing to do. But once you look, on the other hand, if you look at the same, content as being data, then reading is no longer appropriate, because you don't want to read, because reading is the most manual possible way to extract information out of data. So here again, I have an editor over a JavaScript file. Now in this case, I don't have a button to parse, but I do have a JavaScript parser somewhere in my image. It's already available. So when I now parse that one, what do I get here? So let's zoom in. What we get here is, this is with the source code on the left. And now if I go here and I can click on any part, and it will tell me here on the right, this is the abstract syntax tree. So it shows me what kind of thing do I have I'm looking at inside, like the behind the scene part of what I'm normally seeing as code. And that's the other interesting part, because in software, you don't have, like, most people are experiencing software from the outside. Usually that's the user interface. And then people there, we've learned for a long time now, or for we've spent quite a reasonable amount of time of making that interface between the user, the end user, and the producer of a piece of a system. We've spent a significant amount of time learning how do we translate, how do we add this layer there, the UI, such that the user feels better, or ideally is delighted when interacts with the system. And it hit me that we did a great job at it. Once, I remember it was about, no, I think it was like 11 years ago or so. And I opened my bank account and I paid the bill and I didn't feel terrible. And that was really cool because at the beginning, like when I opened my very first online banking, that interface was absolutely horrendous. It was really terrible. And you would then pay the bill, which in itself is not a really pleasant activity. And like the pain would be doubled, right? On the one hand, because you'd have to pay the bill, on the other hand, because you had to go through that interface. But once they changed the interface, I didn't feel terrible anymore. And that's a great thing. There is a way to transform how we are related to some computation in a way that is actually comfortable for our brain, and in a way that might be even pleasant for our brain. But now if you go back and if to this idea that any boundary in software system is actually arbitrary, there is no boundary in software systems. The fact that, sometimes, if you think somebody builds an API and then a user or a developer will then use that API. And the developer is a user for that API. And then the producer of the API is the producer of that system. So that's now the bound. That's the interface that we're talking about. And so it doesn't have this principle that we can change how a human being relates to some computation. We can apply it at any levels of abstractions. It doesn't just have to be at the just where people click at the very end. And that's basically what you're seeing here, right? On the one hand, on the left-hand side, you see something that, like, it's a typical thing that developers would look at, like it's the code, right? It's still, you're looking at it from the behind, right? So it's still inside the software system. But now here on the left, on the right, it's another meta level. You go in even deeper behind the scenes. But it doesn't have to be unintuitive. It doesn't have to be painful either. It can be something that we can enjoy. And then what's interesting is that once you're able to understand, in fact, this whole thing is just a tree, and a tree is something that I can traverse. I mean, I learned to do once, to traverse a tree once, and then I'm just going to be able to traverse all sorts of trees and learn from this data in a very uniform manner, right? Like JSON was essentially a tree, and here we are having a tree. So there's not really much of a difference. And most of the data that you will handle when you will build your systems are going to be just trees. Like, you will get all sorts of information, usually represented as trees, and you're going to transform them into some sort of graphs that you will then reason about. And that's basically what most systems are. And so making this comfortable, making it a core experience at a more abstract level, can change how you're relating to not just few individual pieces, but to how you're relating to software in general. Okay, so let's go now back. So this was about the file system. And let's look at what happens now when we start to combine that one, right? Because here we were introspecting over a system or files that were external to our system. So maybe a JavaScript file in that case, or some file like a JSON on another case. But here we have, for example, a method in object. So if I execute that one, I get an instance of a compiled method. And a compiled method knows how to present itself. So I will see the source code over here. And normally compiled methods look like this, right? It's just a bunch of mumbo jumbo, like literals and various bytecodes over here, right? But because it knows where it comes from, then we can also say, well, here's a source code of it. Great. But then on the other hand, I was saying, well, the abstract syntax tree is also something that is or can be interesting to look at. So here's the view of the abstract syntax tree. And when I look at it, let's say, when I will click on that node, I will see it here. Okay, this is an abstract syntax tree node, and I can see where it is in the source code because it knows how to present itself. It's a very simple thing in the end. It's nothing really complicated here. It's just two views, and they from one object goes to another, and then this object knows how to present itself, and all of a sudden I have a browser that allows me to go to the meta level. But then usually, you know, when you go, the abstract syntax tree is one, and then but at the end, what people care about, or what from a runtime perspective, we care about the bytecode. So if we switch to the bytecode, then we see, okay, this is actually the bytecode. But because now the bytecode, every single bytecode is, let's see this one. Every single bytecode is an object too in a file system. Then this object will know how to present itself too, and it will know how to say, well, I'm here in the source code. So notice how it's very easy, just with simple combinations of tools. I'm transforming this very basic tool, which is supposed to be the inspector, into things that are rather complicated and very short amount of, with very little energy. So now the question is, how is this implemented? So let's take a look at this one, this bytecode here, which basically just shows me a list of bytecodes. So given a compiled method, I should be able to find out what its bytecodes are, and then somehow I want to be able to put it here. So let's think about this for a second. In any language, there will be at least a way to transform an object into some representation which is string. So something that appears, for example, on a console or in some transcript. And let's say in Java, this would be like a toString. In Smalltalk, it would be like a print string. And it has been there for a very long time. But given that this is the 21st century, it kind of makes sense to not have just a toString, but to have a toWidget, because we're not limited to CRT screens anymore. So this is one. And then because there is no single projection that we want to, that is interesting about any specific object, it follows that we should not just have one widget, but basically many widgets. So according to this, right, then where would you then put this representation over here? Well, because this is a live system and objects are extensible, we would put this logic of this view kind of in the same way, or we would treat it in the same way as we treat any other like a print string or a toString. So if I'm now alt-clicking here on this view, so I press Alt and I click here, I am seeing here there's a method, and this method is defining compiled code, and it's called GT_bytecode4, and it gets some a view, it's called here. It's annotated like that, so this is a pragma. It's in Java, for example, this would be called an annotation. And then it simply returns here. It says, well, given this view, I want the list in there. And then the list should have bytecode. I can see that one there. It should have these items there. So I can see, okay, so given a compiled method, I can say, I want the symbolic bytecode. So what are those? Okay, so basically there is some machinery there, which says, well, symbolic bytecode builder, go and decode self. And there's a whole interesting mechanism that takes place there. But at the end of the day, I would just be getting a collection. So let's actually go and check that one. So if I go here and I paste the same code, so now I'm in this, well, self is the compiled method. And if I execute this piece of code here, self symbolic bytecodes, I will get an ordered collection with 22 items. And these items are exactly the same that I'm seeing here. So again, if I go back to this code, that implements the bytecode view. I simply say, okay, this is a list with a few specifications. This is what I want you to show for every item given this list over here, and that's it. So I take 4 or 5 lines of code and I'm creating this view. And this view is, of course, creatable live. So if I'm changing it there, it's changed over here, right? So I can affect these views as I'm working with my system, which basically means it goes back to this idea that, in a living system, you have this possibility of reflection. They are built in, and now we are extending those abilities not only to the language, but to the environment too. So, right, that's basically what we're seeing here. Let's quickly take a look at how the tree here is implemented. So the tree is going to be, again, it's going to be a method. So if I'm alt-clicking there, I can see that there is a method here, a compiled method, which is called G34. And it says, ooh, given the compiled method, I'm first going to take the parse tree. And what is that parse tree? Well, that parse tree is, first of all, it seems to me like I have to decompile it. And then I will, well, no, I have to decompile it if I don't have it. But if I have it here, which again, it's as a whole thing of how do we get it. So from previous lectures, you learned that we have some code in changes files and some code in sources file. And what this one is doing actually here is looking up that code. So given a bytecode, because the image is you just have bytecodes there, and through the and so given a certain method, then you can look up the source code, but that's external. And then once you get it, then you can parse it. Right. So if I have a parse tree, if I'm parsing that, I will get a program node, our refactoring browser program node, which is a syntax tree node. And then that node there will simply say, well, I want a tree there, and I want this to start from myself, and I want to recursively display my children. And that's it. It's a simple representation, a simple transformation. And with that one, we're now having here a new view. And again, this is all changeable live. So this is how these views are being made of, and this is what happens when the environment is then made moldable, right? So just briefly before we take a break, is we are seeing that these views are annotated with GTView. So let's go and find out how many of these there are. So how many views are we talking about? Because we see here a number of them already. What happens now, and this is a plain Glamorous Toolkit installation. So what I'm going to do here, I'm saying given this GTView, and I'm making it as a symbol here, and I'm passing a message which is called GTpragma. So that message is actually simply implemented as some filter object that is being called on top of that. So if I'm executing that one, this is essentially this filter object is like a search that performs a search over the system and provides some result. And this result is, in this case, is a collection of methods. And the filter object knows how to present itself. So how does it present itself? Well, with a list of editors, because these are now methods. So this is here, I can see that I have my GTViews over there, right? And this is a GTView. And notice how this thing gets highlighted there. And the highlighting happens, it's not, it's actually live. So if I now, and it's not text-based. So if I do here GTView, then that one does not get highlighted. But if I do here GTView, it would get highlighted because it's another pragma. So this is actually a live editor that we're having here. And we can go and modify code. And what's interesting here is to look again, like what is the name of this tool? Because we've just written a query over our system. in the playground, and then we are editing code in the inspector. So, right, there's no boundary when it comes to tools, right? We have to, once we are able to combine or see these kinds of tools as being, combinations, then we can start doing really interesting or completely new things that are otherwise difficult to imagine. Now, one other point to mention here is that given this filter over here, right, not only does it know how to present itself, it also knows how to measure itself. So there's a very interesting point here, right? It says, well, there are 1,025 methods. That means there are 1,025 different views in a typical, normal, default Glamorous Toolkit installation. That means there are 1,025 plugins that are active in parallel at any given moment in time. And this is possible because they're very small, right? So on average here, we're seeing the lines of code per method. We see that this is 11.7. So if you remove the name of the method and the pragma, you're basically less than 10 lines of code. And that's basically what makes this whole idea possible. By decreasing the cost of custom tools, we are enabling a whole new level or we're unlocking a different way of working or going through systems that do not necessarily rely on our ability to manually traverse the data. So I would suggest to take a break here, and maybe we start after the break with a few questions and then we continue.
I think we can start again. Thanks, Dora.
So let's see, can we start with some questions? If there are any, hopefully.
Don't be shy.
I just wrote in the Google Docs Q&A document that this is empty. So any boundary in software is arbitrary, and as a consequence, we can rethink the whole experience of how we are approaching all of these layers that are otherwise usually hidden, right? So right now we have UI and then everything else, and then the UI we focus a lot, but on everything else we don't really, and we take we take the development experiences for granted as being the default one, the one that is applied on all other systems. And what we have seen so far is that we can change the development experience on an object level, at the object level. So, and by that, we can also change the larger patterns that appear, because this idea of moldability, that there is no single perspective on software, is actually applicable at all activities that we are undertaking related to a software system. So, right, this is what you normally see when you're opening Glamorous Toolkit. So one thing here on the top right is a search. And so this search object over here will say, well, maybe we'll say, I want to search for object. And then it shows me classes and packages. So I can see multiple of these searches happening. And but at the same time, if I'm going inside the object, so I have this here, the possibility of actually going in. So now I'm navigating into the class object. And if I'm now looking here at GT something, I will see here this method, which is called GTDisplayString, which is the method we just looked before at, right? I also see the view that I just created. I created in the inspector. I see it modified over here, right? This is the bytecode view that I was looking at. Now notice how here we're applying the same principles that we have applied on the inspector, but now we're applying on something else, which is in this case, search. So when we were here at the top, search was basically a global activity. It was just a predicate that was applied to everything. But when I went inside the object, search happened inside that context. Because in the same way that an object knows how to view itself, an object also knows how to search itself. And just by doing this and just having this shell of a UI, we have just built a highly extensible search interface that we can then use to just search indefinitely for all sorts of things, right? So we can have here, if I'm now searching for the // folder, that's a folder, and you can see, okay, here there was this Zooniverse project, and I can see it's there. And if I go inside there, now I'm inside the Zooniverse mobile, right? And then we go inside there, and I can see, okay, these are the sources, these are the directories over here. I have 9 of them, and these are the files. And I can just search, right? I can say, oh, I want the source code, and if I go inside there, I will see inside there. So I've just created with a simple interface. And by just combining also the inspector, and I'm putting the inspector over here, now we have a very extensible way to search. And again, we didn't really, this is not, it's not very expensive. The way to implement the search is very similar to how we are implementing views. So I was saying at the beginning that if we say, I want to say GTView, and I just want to see the pragmas, right? And I can go here, these are the pragmas. And if I go in there, you can see what all the places there are. So I can see here all of them. But interestingly, I can also do GT search, and I can see these pragmas over here. And if I look there, I can see that I have 150 of those. There's 150 these kinds of searches. So let's say that we want to look for the for the class called oops. Let's go back just a second. Let's say that I want to look again for GT search, and I want just to find the pragmas over here. And I'm now going inside there, and I'm going to search now for spotter start. So now this spotter start. This is the object that stays that is basically this is the context in which we are searching in the first step. So here, for example, if I want to see how do I search for classes, I can simply see it here. There is a class called GTSpotter start, and in there is a method GTSpotter for classes that takes a step, and there in this step I want a list processor, so something that just will, given a list of things, I want you to search through them, and the list of things is being taken from here, Smalltalk, all classes and traits, and basically I'm just at this moment I will just look for the substring, just doing a simple string matching, substring matching. And that's pretty much it. This is how we're defining the search. So this whole, and then through this, we can basically we can search any models that we have, and it doesn't have to be hard-coded. And in fact, this tool that we have there, you will find it in other places as well. And you can then use it too in your specific context. So let's look at one of that. Right. So here, for example, we have a coder, and here on the top right of a coder, we have another. We have a search, but this search is contextual for this object. So here, for example, right now I can search. I can look for, if I look for baseline, I will baseline. I can find that I have this method over here, but I also see that there are some other implementers in the system. These are now global ones. The first one is specific just for my class. The rest ones are not, they are just generic. And I can go to some other places that are defining baselines. So again, the interesting thing here is that this spotter is like a generic operator, you can think of it. And then I'm simply instantiating it in different contexts to use it for one purpose or the other. And so this is how we are actually constructing the whole environment. The whole environment is, if you're going to approach this environment as a set of features that you want to see, so how do I do this? How do I do that? How do I do that? All of these. That's going to appear very, very daunting. However, if you're approaching this as a language, because this is how we are thinking of it, so it's just like in the same way as you're approaching learning a programming language, then it will appear much more accessible, because in the end, all of these operators are actually, they're not that many. It's just that the combinations are many. Okay, so that's basically, this is how we're dealing with search. So the same idea of moldability, but now it is applied to search. And the idea of moldability is also applicable to how we are coding. So for example, here, I have a class, and before you saw, methods like or things like this. So I can have self here, and I have a message that's being sent to it, and I can see there's a little triangle there, and I can see how that thing is implemented. So I can see that one in place. And this triangle is actually added dynamically. So if I change something, and if I modify the text, the triangle appears as I type. That's interesting, right? It's essentially, it's added by the syntax highlighting, but once I'm adding it, I can also embed arbitrary artifacts into that place. So this is interesting, but it's rather generic because it's just simply applied on all messages that I'm sending around. And if I can resolve the message to a method, then I'm going to show it to you, and if not, then not. But sometimes some code is very often is built on top of libraries that have more specific semantics. So for example, this baseline of Glamorous Toolkit is actually, this is the specification of all the packages that are making up Glamorous Toolkit. So these are like all the different, you will see, for example, here. And this is the project where we are implementing the inspector and so on, right? So now what's interesting here is that this is something that it's in subclassing baseline of, and there is a method called baseline that is annotated with baseline. And in that method, when we are sending this message baseline with to the attribute that is being passed here, so spec, you can see it there, and then I'm sending this baseline with over there, I'm seeing that there's a little triangle over here, but this triangle is not for the method. This triangle is for the string. And this is interesting, right? So if, for example, if I'm deleting this one and I'm pressing here completion to get control space, I'm getting completion inside the string. And so when I do that, then the triangle appears. And when I expand the triangle, it will show me the baseline method of a class which is called not gtoolkit inspector, but baseline of gtoolkit inspector. Now, why? Because this is the logic of this library, the library that puts together projects and looks them up on GitHub and loads them into the image and so on. So this library has this logic in it. And what we just wanted to do, we wanted to make the coder, the editor, be able to accommodate that specific context. And so that's a small plugin that is being added to Coder, and it's happening live. So these plugins are being evaluated live as you type, and you can build these types of customizations yourself for your own libraries. So this idea of moldability applies here too, even if you do not have a full, you don't need a language to get your tool to adapt to that specific context, right? And again, like here, you can go as deep as you want. Okay, but now, of course, if you do have, sometimes it's not just anything that you want. Sometimes it's also, views like that. So in this case, I have here a graph of all of these dependencies. So If I just want to reason, if I don't want to edit it, but I want to get an overview of what's going on, then this view is much more interesting than the previous one, right? If I want to see why is something not loading properly, or are there problems somewhere, then I will take a look at this map. And then of course here too, if I'm clicking on one of those, I will go into this, I will look at this at the class that was spawned here. So these are all classes, these are all baselines, and interestingly enough, these are the comments of these classes. So for example, if I go here in the baseline of GToolkit, and if I look at the comment there, now interestingly, I see the same view being added into the document that now represents the comment. Now, this comment is, of course, a textual thing, but the way we render it is no longer textual, it's visual. So, for example, here, we're having, if I'm deleting this one, then this whole visualization goes away. And if I'm adding it back, then it appears. And as the cursor moves away from it, there's a markup language there. And as the cursor moves away from it, the markup disappears. And you can simply consume this text as if it's normal, just a document, right? And then, of course, if we click on that, we'll get a new document over there. And from there, we can go on and navigate to different. So basically, see the whole image. We can transform it into a giant wiki and a live wiki to that matter, right? Because here, for example, we have added a full. This is an example of how to show connected objects, or about the inspector. And again, it shows me the current folder, and it's exactly the same kind of demo that I showed you before. But in this case, it's live and it's integrated into a document. So again, the idea of having tools that are highly specific to one single activity and that you split the way you want to reason about your system by the tools is something that we have to outgrow. And what we're showing here with Glamorous Toolkit is that once you turn it around, once you turn the problem around and say, the only thing that I care about are the objects, and all the other ones, everything else that I'm seeing, there's a layer of tooling on top of the thing that I want to look at. And this layer offers me models that are then combinable in many different ways. It's a much more interesting, or it offers a much more rich, or a much richer possibility to express my thoughts. And so to have the tool not force me to adapt to the tool, but have the tool adapt to me. That is the ultimate goal, because that's at the end what will generate pleasure, and is also what generates productivity. So this is that's what we, this is how we are looking at the coding part. Now, of course, if you have other languages, so what Glamorous Toolkit actually is, there's a whole language workbench inside. And language workbench is like a platform with which you can define editors or development environments for other languages. So here, for example, the second language that is actually not far, and that we are supporting in Glamorous Toolkit, is actually the language with which we are defining the support for other languages, right? Only makes sense because in a Smalltalk system, it's all, described in itself. So here we're having an engine which is called SMAC. And what you're seeing here, this is the definition of the parser that I just used in the previous demo for when I was parsing the JavaScript code. So how is this one then defined here? Let's see. Let's find here. Basically, this is the definition. This is the definition of the parser for JavaScript. And well, we can see that we can do it exactly in the same way. So let's say this is a switch statement. Maybe we can find an if statement. It's my favorite. So, and then what's interesting also here is that if I have an if statement like that and I'm pressing this button, I'll get a simulator, which means that now if I'm going to test it. So if I'm now say x equals 42, then it should be returned true. And so basically here now I'm seeing how the parser matched this input text and which productions of it worked, right? So which of the productions I see here. So I can see this is if state, this expression, and in there somewhere next to it, okay, there's a statement over here, right? And this statement, I can see there's a return statement. So somewhere here, this is return statement and so on. So again, what is interesting here is that we get the same kind of interface, but now we are instantiating for a new language. And that is also possible, right? So this idea, like once we started from something very small, the object, and then we are applying the same concepts over and over again at higher and higher levels of abstractions. And that's basically what we get at the end. We get a moldable development environment. Okay, so, and maybe one other thing to show here is there are other ways to integrate logic. So one thing to know specifically in Glamorous Toolkit is that we have introduced this idea of examples, where examples are like tests. Like, so I have some instantiation of an object and I have an assertion here. And but the difference between an example and a test is that an example always returns an object, which means now that I can see here that this face, for example, here is based on some other example, and this one then is based on another example. And but at the end, we can simply execute any of it. So here, for example, because this is an example, I can run it. I can see now it transformed into a green thing, but I can also execute it. And because it returns an object, I can see the preview of it, right? And equally well, I can also take a look at a map of the different dependencies between my examples. I can take a look at them, how to see how they are, composed. I can run them individually, or I can run all of them over here, and fully they run, right? So they are all green, and then yeah, we can look at them like this. So even this, we can imagine all sorts of new kinds of interactions on top of libraries. So in this case, this is a library for how we are expressing tests, but not only tests, we are also expressing documentation. So for example, if I look at the comment over here, I can see that the same object that I saw from here, from this example, I'm now using it as for documentation purposes. And in this case, it just describes actually an algorithm to identify the face landmarks, and the actual algorithm is based on an Azure API that is available publicly. So this is a description of how that one works. Okay, good. So if you take a step back, this idea of moldable development really starts like this. You can always start with the hypothesis, and only afterwards you're going to choose a tool. Never the other way around. And once you have a tool that you're using, you're going to take those results and interpret them. And if you're confident, you're going to act. And this is important. It's important to say that everything we're doing here, we're talking about. I mean, these are like maybe these tools. They look interesting. They look fancy. But at the end of the day, what matters is, can we affect the way humans make decisions about the inside of software systems? So the decision is what matters. Now, this all looks interesting, but that's nothing new here, because this is what is called the scientific method. You take a hypothesis, you apply an analysis, you get the results, you interpret them, and if you're confident, you draw conclusions and you do something about it. If you're not, then you're repeating this one. But when context is so important, then you do not have a tool, and you should always ask, do I actually have the necessary tool for my for whatever I want to check? And if I don't have it, then I should be able to create it. I should be able to mold it, and only afterwards to continue. So this is like, what's interesting here is that the hypothesis and the analysis and the interpretation, these are pretty much at the same level. This is what I'm interested in. The building of a tool, that's a meta level. But this is essential, because if you don't do that, you're going to fall back to the only malleable way we have at our disposal to deal with lots of different kinds of contexts, and that is reading. The only problem with reading is, I mean, we can read anything. The only problem with it is it doesn't scale. So, which means that people will always, so if you're only relying on reading, you're going to be always be making decisions based on partial information, and that's not appropriate. That's not how it should be. But if, on the other hand, we take the same kind of energy and we invest a little bit of it in building the tool, then all of a sudden, new possibilities arise. And if we can actually replace the reading part with more automation, but not generic automation, but custom-made automation. And that's basically the essence of moldable development. So maybe one more thing as to how do we go about doing this. So let's say I go back to this universe mobile, and here I might have a folder with the sources, and let's say that in this sources over here, I want to now get an idea. I can see that there are multiple folders, but there are folders in folders, and so it seems a little bit complicated. So I would just like to get an idea of what kind of things do I have in there. So I don't want to go and click on everything. And instead, I would like to quickly say, well, let's build a visualization instead. So I will say I want a new Mondrian view. If I execute that, so Mondrian is a little object that knows how to draw itself like Mondrian. Mondrian was a painter, and then he saw the world in terms of boxes and lines. So this is a tool with which to draw graphs. So if I have here nodes, I have to specify the nodes, and then we will say, well, here we want all the directories. I just want to find out all these directories that they have, and if I execute that, I can see them here. Right, so they appeared. And now what I need is I need also some edges, and I want to connect these edges from, let's say, given a directory, it knows its parent, so I can draw them like that. And if I now lay them out as a tree, let's say, then I can see something like this. And what's interesting about this whole thing is that this view over here, these are not just boxes. So if I click on that, those are actually the objects behind them, because these are models, but they are only projections on the objects, which means that I can go and click on any of that, and I can go and then afterwards continue my navigation. So what just happened here is that I had a problem. It's a very basic problem, but then I said, well, I was not satisfied with the tools that already exist. And so I took a little bit of time and I created a new tool, that tool. And that tool, I can promote it to be a view, or I can just gonna use it for a bit, and I'm going to throw it away. So that's how this process actually looks like. And because we can make the tools, these custom tools cost almost nothing. Because of that, this whole idea is actually possible. Okay, and then of course we can take it a little step further. You're going to see more about this idea in a dedicated lecture which is about software analysis and MOOS. So writing Glamorous Toolkit, it comes with the core engine of an analysis platform that does even more sophisticated types of analysis. So here, for example, I take that same Zooniverse or React Native thing, and there, for example, in React Native, you can have things like that. So this is a component. And a component, for example, this is a button. And you can see that this button is using something like, I don't know, touchable opacity and so on. So this is like This is not exactly JavaScript, this is React on top of JavaScript. So this is another set, like a library on top, but it has some interesting language extensions. Like this is called JSX. So one problem that people have with these types of applications, so React is one probably the most used by now in the world, the most used library, but still people have problems. And when we were playing around with the mobile application, and within just a couple of weeks, we got into this problem of circular dependencies. Like we were having you could define these components and you can say how they embed each other, but then we found ourselves like keep on getting into this circular dependency problem that you only find about at runtime. And so it's really expensive and it's annoying to reason about. So then we built a little tool. And this tool then basically says, well, given some component over here, I will see here that this render button is actually using a button. I can see it there, right? And so this one now gives me the view over that graph, something that I would otherwise I would have not seen. So that's another example of how you have a problem, right? And then you say, well, I'm not satisfied with the tool. I'm going to take a little meta step. I will build a tool. Some of these tools might be more expensive than others, of course, but then you have to always compare it with the alternative, and the alternative is not having a tool. And let's say that you have a team of 5, 10 people, and then maybe you're going to work on this system for a year. How much are you going to how much will not having a tool cost, as opposed to maybe spending some days or to building one? Because when you're having a new language, that is much more of an expensive thing to build, and that indeed is something that you want to be able to reuse later on. But simpler things like the visualization that you saw before is something that is doable in a matter of sometimes minutes. So, but usually you have to, or we are comparing the applicability and the impact of Moldable development with the alternative of not having any custom tool. And there it's very obvious that you actually want to take the time and learn how to invest in these custom tools. So talking about tools, every time we talk about tools, we always think about these tools are these things that just augment ourselves and then they will do exactly what we want. But in the previous century, Marshall McLuhan was looking at a similar problem. And the problem was that the TV and radio were massively introduced rather abruptly for example, in the American culture, and within just a matter of a decade. And the question that he was asking is, how will this affect culture? And then, of course, by now we know that the culture was affected dramatically. And then we see, for example, today what's going on with Facebook or similar problems. And then one of the things that he was talking about, and then summarized by his colleague John Culkin, was this idea that we shape our tools and thereafter our tools shape us, which means that if this is true, we should be very careful with the kinds of tools that we expose ourselves to, because they will decide how we're going to think. And now if you take a step back and you look at the kinds of things that I showed you here, and maybe compare with the typical development experience, where the only thing you see is a giant text editor, and how those tools will enable you to do one or the other, this becomes quite evident that this is so. Now, this is why we are looking at the environment as at a meta level, like we are looking at the characteristics that the environment should provide in order for the behavior to not be so destructive as it is now. Because developers reading code as the only means to extract information out of systems means that everybody that makes decisions about that software system will have an incomplete perspective on that software system, because simply reading is not appropriate. You cannot extract, you cannot deal with the size of software systems like that. And that one not only has, technical implication, it has business implication, but it also has social implications. So every time you're going to hear people talking about how a system has done something because that's what the algorithm said, that's basically people saying they don't know what exactly is that algorithm is doing. And that's not acceptable because we are reshaping the whole world on top of software. And we have to take it's our responsibility as developers to create or to put in place new properties that will enable afterwards new kinds of behaviors. So, as I said, like this is why we're looking at the environment as a language made out of visual interactive operators. And the goal here is to be able to combine them in many different ways, right? And this language extends the normal, the underlying language, the Smalltalk language. And it's basically a continuum, right? And the same principles that apply on the Smalltalk language, like how do you, for example, that the tools or that the system should be able to reflect upon itself while it works is important. So for example, here, this very slide, right? I can always take a look at how it is implemented. And I might change here something, right? And then it will be updated. While I'm giving you the talk, I can go and change those those slides. Okay, so that is basically what I wanted to talk to you about. And at the end, I was showing you a couple of things. So we started from this idea that objects there is a way to transform how we relate to even one single individual object. And then by doing that, because software has fractal-like properties, we can apply the same principles at all levels of abstractions. And through that, we can change the way we experience the inside of software systems. So what you're seeing here, this is a map of the whole Glamorous toolkit. And every box here is a class. And the classes highlighted with blue are those classes that have at least one object extension. So at least one GTView defined specifically on that class. And with green, you will find all the classes that have examples. So what you're seeing here is that these are two of the operators that we are having, examples and views. And you're seeing here how the whole system is affected by this. Like we need these principles are needed throughout the system because the moldability is a pervasive need. And what Glamorous Toolkit is not only an environment that enables this way of thinking, it's also a case study for how this way of working actually works in practice. So thank you very much, and I'll be happy to answer your questions.
Thanks a lot, Dora. You can ask questions in any form they like. Use the chat or raise your hand if you don't want to write down a question. But we do have a bunch of questions now in the Google Doc.
Let's see. It said an object knows how to search itself. Does it mean that we add additional responsibility to an object that are probably not part of the domain? Yes, exactly. It does mean that we are making the object know more than what the domain is. Just like how, for example, you're having a print, like the toString method is not part of the domain, but yet you're still going to need it. So that same need is available here. Now, interestingly, in Smalltalk, you don't have to package your method in the same place where you're packaging your the class. You can actually have method extensions. And so that's one way if people are concerned with deploying things at runtime that maybe don't belong at runtime, that this is a way to handle that problem. Do you, in that case, make subtle distinctions between what is the part of the underlying model and what is not in your implementation? I'm not sure I understand that part of the question. If you would want to clarify, I'd be happy to address it.
So, hi Doru, this is Nitish here.
Hi.
Yeah, just to clarify, so I was referring this from the domain-driven design perspective, and as I understand, so it promotes that the objects sort of should know things that are related to domain. They shouldn't do much more than that. So I was just trying to understand with this question. So when you design your objects, let's say, do you carefully decide what is going to be the part of the domain and what is not? I mean, does it reflect in your implementation as well? Do you make like a distinction between it somehow?
Well, those are just methods. So the GTView methods are just going to be methods in the object, nothing else. So just normal methods. And you're going to use them for different purposes, just like you're actually using your objects for different purposes.
Mm-hmm.
So, and the way you're, most often the way we're distinguishing those are actually when we're writing queries against our code. So let's say, oh, I don't care about the GTView. Okay, let's filter them out. And that's just it's mostly a query problem,
Mm-hmm.
if that's a specific concern.
Yeah, okay.
How do you distinguish between software modeling and domain modeling? There is no distinction. It's just, as I said, all boundaries, all these terms, they are made to, or based on some, that people think, oh, domain modeling is hard. So, I mean, we don't know how to do software modeling. So at least let's do something with domain modeling. So then we give that one a name and we're going to optimize for that one. But it doesn't make any sense because, like, for example, you saw the example with the pictures and with the landmarks detections. That's actually a domain. I have the concept of a picture. I have the concept of a landmark. That's a domain model. But on the other hand, is also an algorithm. So what's the distinction between them? It's just how you look at it. That's the only distinction. Any boundary in software is arbitrary, and any solution that works only for something is probably going to be incomplete. So I think that we can do better, and we look. If we stop seeing all these distinctions, everything becomes much cheaper. That's why so we could build Glamorous Toolkit specifically with a small team, because actually this is not a very complicated domain. It's just that it's complicated to stop looking at it in a complicated way.
Mm-hmm.
Once you stop doing that, things become much simpler. Okay, how hard would it be to develop similar moldable tools for other languages and IDEs? Well, I don't know about the other IDEs, but I showed you already other languages, right? In fact, Glamorous Toolkit is a platform for building your system-specific IDEs, and I already showed you how. So you can see that on the one hand, you need the parser. On the other hand, you need you will need access syntax trees, and then on top of it, you need editors, and then on top of it, you need maybe debuggers and inspectors. And so I showed you at least half of that problem already, and the principles apply. They do not only apply on Smalltalk. And as I said in the software analysis lecture, that demo that Andrei Kish will give, our colleague, he will be showing you how you can use Glamorous Toolkit already to at least reason, for example, about systems written in other languages. Right, so of course, having a reflective system is important or is relevant, and you will be able to do, modify your systems live if you will have that capability. But even short of that, you can still do much better than the typical development experience that exists today. In fact, like we have a business specifically because we're helping people using state-of-the-art tools to actually make sense of the system that they have written themselves. So that might be a validation of this idea. From the discussion, it looks like you're crafting tools to assist developers to comprehend software by giving them ability to craft views. Or does it also mean that we should craft tools for other stakeholders. Oops, for other stakeholders of a software. Yes, of course. As I said, a developer, like any boundary in software is arbitrary. That means also the distinction between the provider and the client and the consumer is also arbitrary. Sometimes we are, so if I'm a developer and I'm consuming an API, I'm a consumer. But if I'm through that API, I'm building the system and I'm providing it to somebody else, I'm also a provider. So anybody is a stakeholder, or can be a stakeholder, is a stakeholder. Anybody that has to say anything about a software system is a stakeholder. That person will need accurate information. The only way to get accurate information is through some sort of tooling. Now, the tooling cannot be generic because value is always contextual. As a consequence, the tool has to be custom made. On the other hand, so the alternative is what people are doing today, which is drawing on a whiteboard or creating PowerPoint slides. Now, a picture on a whiteboard or in a PowerPoint slide is one of two things. It's either a wish or a belief. If the system doesn't exist, then it's a wish. It's a good thing because then you'll say, okay, this is how we think it should look like, so you can visualize it before it exists. But if the system does exist, then that picture is a belief because this is how you believe the system to be. And beliefs are not a good thing for making any decisions. Making decisions with and about software is already complicated enough, and we don't need the aggravation of not knowing what the reality is. So there is such a thing as fact, and knowing what those facts are is actually meaningful. And again, the only way in which you can possibly scale to the size and the speed at which systems change is by means of tools, and you'll need custom tools in order to in order for them to be also valuable. So as I understand, your motivation for developing GT was mainly idealistic. How broad is GT used in industry? Do you make any money with it? If so, how? Was it idealistic? You can maybe say that it was idealistic, but it was primarily grown out of frustration because I am not able to to hold so much information in my head as it is required by the typical tools that we are experienced that people are using today. So I needed other kinds of props, and that's basically why we built GT. But yes, it was a little bit idealistic probably, and it still is because our goal is to change how developers relate or how humans relate to the inside of software systems. There's still a long way to go there, and GT is just the first step. To get how broad is it used in industry? Well, we've just released the beta version a couple of weeks ago, so it's a little early for that one. But the original version, the first version of GT, is actually shipped with Faro, and Faro is already supported by a consortium of industrial partners. But the current GT is a distinct project, and it's a much broader in scope, and it has its own vision that is separated from the Faro one. And we will see how this one will work in practice. Do you make any money with it? Well, we don't sell it. It's free and open source, and our goal is to educate people as to why they should start talking about how they read code. Yeah, we do get funding, and the funding is acquired through consulting. So externally, we are a consulting company, and internally, we act like a research lab. And all our consulting is actually done through the tools and techniques that we are developing. And so all the industrial projects not only act like a source of funding, but they also act like a validation for the hypothesis that we put forward. And basically, what you're seeing from Glamorous Toolkit, these are tools that we have actively used in real life projects way before others started to use them. So
do we have any final spontaneous question? If not, our time is pretty much up. So I'd like to thank you, Doro.
Thank you.
A very nice presentation. And I'll be loading up the podcast later today once I've edited out the blank parts.
Great.
Thanks a lot.
Thank you very much. Bye.
Bye.